All right, guys. Today, this video is going to be about the mole calculation activity. And so, in this activity, we're just going to measure the mass of some different objects, and then you guys are going to convert from the mass into the number of moles, and from the number of moles into the number of particles. So we'll start on question one. This is a piece of copper metal, pretty small piece of copper metal. We're going to weigh it, and right there you can record the mass of this piece of copper. And then what you're going to do is convert from grams of copper into moles of copper. To do that, you're going to use the molar mass, which you can find on the periodic table. And then once you know how many moles of copper this is, you're going to convert from moles into number of atoms. And to do that, you'll use Avogadro's number. All right, so that's your piece of copper. That's for question one. On the third question, you're going to be doing kind of the same thing for a piece of carbon. So this is a sample of carbon, and we're going to find the mass of that carbon sample. So you can record that number as the mass of the carbon, and then you're going to do kind of the same conversions. You're going to go from the mass to the number of moles using the molar mass. You're going to need to look at the periodic table again because carbon does not have the same molar mass as copper. Right? They're different elements. They have different types of atoms. And so the molar mass of carbon is different from the molar mass of copper. So look that one up and make sure you use that mass to convert from grams to moles. And then once you have moles, you're going to convert into number of particles, number of atoms. For that, you'll be using Avogadro's number again, 6.02 times 10 to the 23rd. You're always going to use that number. It does not matter what the substance is. You always use that same constant for the mole, 6.02 times 10 to the 23rd. On the fifth question, you're going to have a piece of aluminum. So there's a piece of aluminum foil that I folded up a little bit. So a pretty small sample of aluminum, but it still has an enormous number of particles in it. So you can record the mass of that aluminum sample and then convert from the mass in grams into the number of moles using the molar mass. Again, you'll have to look up the molar mass on your periodic table for aluminum. It's different than the mass of carbon or the mass of copper, and then convert from moles into number of particles. In the second part of the activity, you're going to be measuring some compounds. So we first did elements, now you're going to be doing some compounds. So the first compound we're going to do is water, H2O. So this is our sample of water. I just zeroed the balance with an empty beaker on it. Now I'm going to pour our sample of water in so we can measure the mass of this sample of water. So there you go, that's the mass of the water. Water is a compound, so you can't just find water on the periodic table. You can find hydrogen and you can find oxygen, and you'll be able to add those together. So for water, it's H2O, so hydrogen has a mass of 1. You need to add that twice because there's 2 hydrogens in a water molecule, and then plus the oxygen, which is 16. So it has a total mass of 1 plus 16, which is 18 grams per mole of water. So you're going to use that molar mass of the compound water to convert from grams into moles, and then from moles into number of particles. The particles, we're not going to call them atoms, we're going to call them molecules this time. You still use the same constant, Avogadro's number, 6.02 times 10 to the 23rd, but it's 6.02 times 10 to the 23rd molecules per mole instead of atoms per mole. All right, so that was the water. And then on question 8, we're going to do another compound. The next compound we're going to look at is sodium chloride, NaCl. So I was just zeroing the balance with that weighing dish on it. Now I'm going to pour our sample of sodium chloride in. So you can record your mass of sodium chloride. And just like with water, sodium chloride is a compound. You're not going to find sodium chloride on the periodic table, but you will find sodium and you will find chlorine. And so you can add those two numbers together to get the molar mass, and that's what you'll use to convert from grams into moles. And then we've got one more for question 10. We have one more compound, and this one is magnesium sulfate, MgSO4. So I'll pour that in, and you guys can record the mass of your magnesium sulfate. And for magnesium sulfate, you have magnesium, sulfur, and 4 oxygens. So you're going to need to add all those together to get the molar mass of magnesium sulfate when you're converting that from grams into moles, and then from moles into number of particles. All right, that should be all the data you guys need. Let me know if you need any help with any of the calculations.